Similarity. If two shapes are similar, that means they are connected by a scale factor. And if I can divide two lengths which correspond to each other on the two shapes, I can find that scale factor. I can then multiply or divide by it to find measurements on the other shape. So I'm going to show this approach with the first question. Here on this question we can see the corresponding sides are 15 and 5. If I divide 15 and 5, I get a scale factor which is equal to 3. So if I multiply the smaller lengths by 3, I would get the bigger lengths. And if I divide the bigger lengths by 3, I'd get the smaller lengths. Therefore, to find the length of EF, I have to take this 16.5 over here and divide it by 3. So we're going to go 16.5 divided by 3, and we're going to get ourselves an answer. That's 5.5 centimeters. Now I'm also, just for this first question, going to explain this a different way, because in a few of these worksheets, the exchange rates, the pie charts and so on, we've been talking about leaving one land and going to another by dividing and multiplying. And we can indeed do the same thing here. So the exchange rate between these triangles is on the big triangle and on the small triangle. 15 centimeters on the big triangle corresponds to 5 centimeters on the small triangle. And what this does is give me an exchange rate from big land to small land and vice versa. So if I've got a measurement on the big triangle of 16.5, sorry, let me just correct that. If I've got a measurement on the big triangle of 16.5, then what I can do is take that measurement on the big triangle, divide by the big triangle number to get out of the big triangle, multiply by the small triangle number to get into the small triangle, so that's a 5 of course, and that would once again give me 5.5. So if you would prefer to use the exchange rates approach, then that's an example of how it works. Just have big land and small land and use those as your exchange rates with your dividing and your multiplying. For the rest of this worksheet, I'm going to use scale factors because that's the most common approach. But if this approach appeals to you and it makes sense, feel free to use it. It will get you the same results. So in this next question, I'm looking for a pair of corresponding sides, either for the exchange rates or to find a scale factor, and I want to do a division to work out my scale factor now. So there's my corresponding sides, 15 and 12.5. I'm going to divide these by each other, getting a scale factor of 1.2. So to find the value of x, I'm going to need to go from the small triangle to the big triangle. The 5 needs to get multiplied by 1.2 to get the x. So 5 times 1.2 gets me 6, and that's the value of x. But for y, I'm going from the big triangle to the small triangle. So I'm going to take this 12, which corresponds to the y, and divide that by 1.2. And that's going to get me 10 for y. Now, I know I said I wouldn't talk about exchange rates anymore, but I'm going to do it one more time just for the purposes of this question. So I'm going to just rewind a little bit, forget about the scale factor, and make an exchange rate. I need a measurement on the big triangle and a measurement on the small triangle to build my exchange rate from, and that's going to be the 15 and the 12.5. So let's say we want to find out x. We need to know where we're coming from and where we're going to. So 5, which is a measurement on the small triangle, needs to turn into a measurement on the larger triangle. I've got to divide by the small triangle number, times by the large triangle number, and that's going to get me where I want to go, and that will come out as 6 if we do it on your calculator. To find out y, I need to figure out where I'm going from and to. So I'm going from the big triangle to the small triangle. What this means, of course, is I need to divide by the big triangle number to get away from it, and times by the small triangle number to go towards it, and that would give me 10. So there's another example of the exchange rates approach, and now I really am not going to talk about it anymore. Next question. These two shapes are mathematically similar, and I want to calculate some lengths. So I'm looking for corresponding sides that I can stack up against each other to make a scale factor. My scale factor here is going to be 9 divided by 6, which is 1.5. To calculate the length of BC, I need to find the corresponding length on the smaller triangle, 8, and times it by my scale factor, 1.5, and that gives me a length of 12 centimeters. The length of EF, that's on the small triangle, so we need to find the length on the large triangle that corresponds to it, and I need to divide because I need the length to get smaller. So 7.5 divided by 1.5, that's going to give me a length of 5 centimeters for EF. And I shall do the rest of the solutions on the next video.